Okay, in the previous question, we looked at the child on a merry-go-round moving with a tangential velocity of 1.5 meters per second while she's sitting at a position that's 1.1 meters from the center. And we figured out her centripetal acceleration using the following equation, v squared over r. And when we did 1.5 meters per second all squared over the radius, which was 1.1 meters, we ended up getting 2.05 meters per second squared was the centripetal acceleration. Now, in addition to this question, they want to know how long it would take for her to complete one revolution. So the time it takes to complete one revolution is known as the period of motion. So we have a choice. Now that I know my centripetal acceleration, I can use the other version of the equation, 4 pi squared r over t squared. So we know AC, it's 2.05. We know the radius, it's 1.1, and we're solving for t. Or I can keep it a little bit simpler and say that my tangential velocity is simply the distance divided by the time. And the distance once around the circle is the circumference, which is 2 pi r. So that's the length, the path length that person will travel when they go around once. And the time it takes to go around once is, by definition, the period of motion. It's a simpler equation, so I'm going to use the second one. So velocity is 2 pi r over t. Remember, that's just d over t. My velocity was 1.5 meters per second equals 2 times pi times 1.1 meters. And the period of motion is what we're looking for. So when I solve this for t, multiplying both sides by t first to get it out of the denominator, and then divide both sides by 1.5, I'm going to drop the units at this stage to make it a little clearer. I get 2 pi times 1.1 on the top, and I'm dividing that whole thing by 1.5. And when I do that, I get the period to go around once is 4.61 seconds.